So you get a problem like you need to find the sum of all even valued terms in the Fibonacci sequence, which do not exceed 4 million. It's a bit of a mouthful, but let's solve it. All right, I'm going to refactor it a bit. So I'm going to put brackets after the sum. So now it's sum brackets, even Fibonacci, which do not exceed 4 million. Okay, I'm going to make it look a bit more like code. I'm going to put the Fibonacci at the beginning. That's the data we're going to go over. And then the conditions. So now it's sum of Fibonacci, which are even, which do not exceed 4 million. Okay, still not really code. I'm going to put this weird stuff in. So let's say we define some fib. That's going to be Fibonacci. So now it's some Fibonacci. And then it's pipe symbols. These are called pipe outside of Python. And in Python, they're usually called OR. You use them to like OR bits or numbers. So now it says some fib. I'm going to say pipe, only even, pipe up to 4 million. It's still not really code. Let's keep going. I'm going to add two operators. So it looks like there's functions. So it's sum of fib, pipe, where, even number, pipe, take while, less than 4 million. So I've added these two operators, where and take while. It's still not quite code though. All right, I'm going to lower it one line so I can go on GitHub with less than 80 characters and no one says the pull request is bad. And finally, I'm going to change what's inside the operators into actual lambdas. So I have sum of fib, pipe, where, and I'm giving the lambda that says this number is an even number. And then I'm going to pipe into take while with the lambda. This number is less than 4 million or up to 4 million. So now this is valid Python syntax. It's not going to work just yet, but this is now what's called infix notations. The operator where and take while, they take data from the left, or for you it's from the left, and how they operate is on their right. So for example, where takes the data fib from its left, and how it operates on fib is written to its right. Lambda x mod 2 is 0. And this is the in the infix notation because it's in between the two, in some sense, arguments. Like plus gets a plus b, plus is in the middle. Here where is in between two things. Let's get this code to actually work as Python. The first part is the easy part, and that's the fib. What we want fib to be is the infinite sequence of all Fibonacci numbers. We're going to use a generator to do that. Generator, I'm going to yield 1, 1, and then keep going. I'm going to get the next Fibonacci number. If you're not familiar with generators in Python and infinite sequences, look it up. It's fascinating. So here I go. The next Fibonacci number is the sum of the last two. There's an example here of the first 5. I create an instance and then call next 5 times. 1, 1, 2, 3, 5. I've heard this has something to do with bunnies. All right. Now we want to get the where and the take while to work. So they were getting on the right like a function call, a condition. And then they were getting on the left something through pipe. Now, pipe from the left is actually implemented in Python as the right or function. And that's this thing here. So I am doing a dunder. This is usually called as its double under, and the roar. So dunder roar, or for short, the Dror function. I'm not going to call it like that, but you may if you want. All right. Let's do the where first. So I'm going to create a class where. In its initializer, I'm just going to save the condition. So when I do where on function, it saves that function. And then when I use the pipe on the left, what I'm going to do is return a new generator that takes a data iterable and returns the generator such that it goes over all of the elements and only yields those that satisfy the condition. And this is exactly our where of some condition. Here's an example, 1, 2, 3, 4 into where even numbers. If we print the object itself, we see it's a generator. And if we actually apply list to it, then we get just 2 and 4. All right. Let's do also the take while. Again, in the initializer, we save the condition. This time in the roar function, we're going to go over the data until it doesn't satisfy the condition. Then we'll break and stop the iteration. But until then, we can yield all the elements. So here is 1, 2, 3, 4. We take while the number is less than equal to 2, and then we get this time 1, 2, and on 3, the generator will break out. We can run the actual original code now. Sum of fib, pipe, where, even, pipe, take while less than 4 million. And this is the number. And I've checked this. I think this is correct. You can check out this GitHub, not by me, by a guy called Julien Parra, I think, /pipe. And he wrote all of these other pipes pre-made, map, skip while, take, tail, islice, unique. You can guess what these do. And there are more that I couldn't guess what they do, so I didn't put them here. I hope you enjoy using Infix notation in the future. And that's it.